Thank you all for coming. We had a slight change in speakers, and John Kaufmann graciously volunteered to talk to us about the climate emergency that's coming up. So appreciate John, and without further ado, let's start.
Thanks. This is a talk that I gave about 2 years ago, two and a half years ago to ICL. I am a member, of course, for those new people here. It's a talk I did about 2 years ago, and it's ready. It was ready to go. But being a little bit old here, 2 years old, it might be a little bit of a rougher presentation today. I'm not quite as rehearsed on it. So I might do a little more reading than talking than I would like to do. So please bear with me. To get started, there are 5 people on a plane about to crash. There are 4 parachutes. The 5 people are Dr. Fauci. This joke is a little bit old, you know. Okay. Dr. Fauci, the Pope, Donald Trump, Oprah, and Greta Thunberg. Okay? 4 parachutes. So Fauci grabbed the first one and said, you know, again, this is going back to COVID times. Fauci grabs the first one and says, I have to save the world from the pandemic, so I'll go first. Pope comes in, takes the second one, says, I have to provide spiritual guidance to the world, you know, during this pandemic. Trump comes up third and says, I need one. I am the smartest person in the world. The world needs me. 2 people, 1 parachute left. Oprah turns to Greta Thunberg and says, you take the last parachute. I'm much older. I don't have much longer to live. You know, you could do something to help save the world from the climate emergency. Greta says, no problem. You take one. There's 2 left. I gave the smartest person in the world my backpack. Okay. It worked. So, and I will come back. That's kind of my segue. First of all, just before I get into the segue, the agenda today, you know, for the talk, as I'll provide a little bit. First hour is mostly going to be the science and the evidence for climate change. The second half, I will go on to the consequences, who concurs, who doesn't concur, and then recommendations. Actually, I guess I'm taking the break somewhere else, so we'll see what happens. I may not finish this talk. I probably will skip over some slides in the interest of finishing in time. So Donald Trump, coming back to Donald Trump. He said that the winter storm that hit the East Coast this last week is proof that climate change is a hoax. He says, whatever happened to global warming? He misunderstands, of course, the difference between the weather and the climate, which I will get into. Last July, the Trump administration released a report that said that climate change is only a minor threat and that strong policies are not justified. They have consequently withdrawn from the Paris Accords last year, 2025, when he came into office. Just this month, he withdrew from the UN FCCC. You all know what that is, right? No hands? The UN, you got that. The United Nations, okay? The United Nations Framework on the Convention for Climate Change. It's basically the international group that then sponsors the IPCC, International Panel for Climate Change, that does all the scientific research, gets people from all over the world to, you know, look at the evidence. This last month in December, they closed in Denver, Colorado, or Boulder, the NCAR, the National Center for Atmospheric Research, which is one of the 2 or 3 top centers in the world for climate research. They have cut funding for climate research. They have cut funding for renewable energy. He has a vendetta in particular against wind energy and has canceled all the offshore wind projects that were already under construction. And he has removed data and reports from federal websites. EPA has rolled back 66 climate-related regulations, and they have canceled, and they have called for the revival of coal. Okay. I worked, just as a little background, I worked at the Oregon Department of Energy for 30 years and concluded my career working for 2.5 years up at the Pacific Northwest National Laboratory up in the Tri-Cities of Washington. I gave my career to working in energy and in climate change. And seeing what the Trump administration is doing just gives me a pit in my stomach. I mean, that's really the only way I can describe it. 2023, when I gave my talk last, I gave it actually in January or February of 2024. That time, 2023 was the hottest year on record. You see it up there? And it was a significant rise from the previous highs. But you can see how climate change, the world temperature has increased since 1900, and especially since about 1970. However, that was 2 years ago. 2024, the next year, wound up being the hottest year. It surpassed 2023. In fact, it was the first year then that won over 1.5 degrees centigrade, which is about 2.8 degrees Fahrenheit. And that is the mark that the international community has kind of said, we need to stay below this 1.5 degrees or we're going to have some pretty severe consequences. Well, 2024, we hit it. We surpassed it, but only by like 1/10 of a degree. But, it kind of marked a point. Now, they don't say that we have reached 1.5 degrees yet because their definition, I don't know exactly what the definition is, but it's something like it has to exceed 1.5 degrees for like 5 years in a row or 7 years out of 10 or something. So they won't make that determination that we have exceeded the 1.5 degrees until it shows a continuous longer-term trend, not just a one-year blip. But then 2025 came in, and you see it there on the far right. It comes in as the third highest year. So we're still on a pretty high trajectory. In fact, the last 13 years have been the 13 warmest years on record. 2023, of course, you can read there a little bit of what the consequences were while I go about trying to find my cards. So they are here somewhere, definitely here somewhere. Okay, we got it. Extreme weather in 2025, which again, I didn't have time to, last night I got the call at 8 o'clock. I didn't have time to put a slide together. 2025, we saw $115 billion to $250 billion worth of damage in the United States alone from the various storms and wildfires. That includes the wildfires in Pacific Palisades and Altadena in California last year. It includes the flash floods in Texas that killed the kids on the whatever river it was, I can't remember. The year before, 2024, again, after I had made this original presentation, there was the Maui wildfires. There was the flood in Asheville, North Carolina, because of Hurricane Helene, and there was the big flooding in Fort Myers, Florida, from Hurricane Milton. In 2025, worldwide, I said the U.S., but we also had it in 2025. Jamaica, the island of Jamaica, was basically destroyed. And that follows, of course, from Hurricane Maria a couple of years ago, which did a pretty good job on Puerto Rico as well. And of course, you don't hear much in the news these days, but Puerto Rico has not been, we haven't given enough aid to Puerto Rico to rebuild, and basically nothing is going into Jamaica. So, monsoon rains in Southeast Asia killed 1,400 people last year, and 5 million acres of Canadian forests burned down last year. And that follows 5 or 10 million acres like the year before. I mean, it's on a pretty bad trajectory. So what's the science? Why is Donald Trump wrong? There are 3 converging avenues of evidence. There's the fundamentals, the physics and the chemistry, what the physics and the chemistry tell us is going to happen. There's the empirical data, where we go out and measure stuff to confirm the hypothesis that we get from looking at the physics, from the fundamentals. And then there's the paleoclimate record, looking back in history, what has happened. As CO2 has risen, can we tell anything from the paleoclimate record? And I think we'll be having a talk later this term that will probably get into some of the details on that. Big pictures are that climate change, or climate, is an energy issue. Fundamentally, it comes down to energy. Fossil fuels emit carbon dioxide. Carbon dioxide traps heat. Trapped heat accumulates and warms the atmosphere. Pretty basic, simple physics here. Heat equals energy, and energy fuels more active and extreme weather, which is what we are experiencing around the world. Fundamentals for climate change. We'll skip this one. Yeah, the rest is details. Okay. Yeah. So they look at the carbon content of fossil fuels and how much fossil fuel has been burned. From that, they can then extrapolate how much should be in the atmosphere, how much has been absorbed by the oceans, how much has been absorbed by trees, and how much is left to warm the planet. And that, in a nutshell, is what's going on. They just kind of trace those flows of where the carbon is going, where it comes from, where it's going, and the rest is details. The history of climate change, I won't go through these individually. I think you can see there that it goes back to the 1800s, where they started studying some of the climate issues. They weren't studying climate change, but they were trying to understand what happens with carbon dioxide, with CO2, and that it in fact traps heat. Now, they didn't relate that to the atmosphere. They just knew it's a gas that traps heat. But over the years, other people experimenting, they were able to determine that it is warming the atmosphere. And again, the diagram basically shows solar coming in, gets radiated out, but because where is that pointer? So it gets radiated out, it is trapped by the atmosphere. The more carbon dioxide you put into the atmosphere, it's like adding a blanket. You're putting a blanket on. You get warmer when you put an extra blanket on at night. That's what the CO2 is doing. It's putting an extra blanket on, so it traps more heat, warms the planet more. They know the fundamentals of the chemistry, and I won't go into that. We can ask Mark Blackburn, he can tell us. The fundamentals of the carbon cycle, we know where the carbon is, we know how much we're adding to the atmosphere, we know where it goes. So we can make, in other words, from this kind of information, we can pretty much make some pretty good predictions about what is going to happen in the future and what is happening today. The source of the added carbon, of course, is fossil fuels primarily, but not exclusively. You can see that the fossil fuels from industry, transportation, and electricity production are 3/4 of the pie, roughly, and about 1/4 of the pie winds up being livestock and land use conversion. And the land use conversion is mostly for growing beef. It is also for urbanization and other things like that, but most of it is converting land from forests in the Amazon into ranch land. The fundamentals of the solar cycle. You have the Earth's energy budget. We know how much energy comes from the sun. We know how much is reflected. We know how much gets absorbed by the clouds, how much gets absorbed by the earth, how much gets absorbed by the water, and how much remains. You know, again, it's pretty for those who are involved in it, it's fairly simple physics. The indicators of a warming world. Now this is when Alan, can I use one of these? There, okay. You can see all the different things here. I don't know if you can read it from back there. I'm not going to go through every single one, but these are indicators. This is where we start to get into the empirical data that I said. They are able to look at what's happening in glaciers and the ice sheets, you know, the melt on the glaciers and the ice sheets. They're able to look at Arctic sea ice, which again, I'll have some slides in here, but the Arctic sea ice is melting. They're able to look at ocean heat content, where they drop thermometers down into the water and are able to measure the ocean heat content. And it is rising, as you can see from the arrow here. Sea surface temperatures are rising. Sea levels are rising. The ratio of I won't get in that one. Air temperatures are rising. There's changing rainfall patterns. The number of hot days are rising, and the number of cold days per year are declining. Does that tell you something? On and on. So, again, we're able to measure a lot of these things, and those are the indicators that they use to verify that, in fact, the physics and the models are right. So they use that data to basically to truth things up, to true it up. You know, they make the predictions from the chemistry and the physics, they true it up with the measurements. The Keeling curve goes back to 1950. He was out of San Diego, and he measured the parts per million of carbon dioxide in the atmosphere beginning in 1958. And you can see the rise of carbon dioxide. Actually, I don't need this anymore. You can see the continued rise of carbon dioxide in the atmosphere since then. You know, every year, just a steady progression. And the up and down is simply, you know, wintertime things in the northern hemisphere. Plants are not growing, you know, and that, you know, so they're not absorbing the CO2. So you get a spike and vice versa. And in the summertime, it goes the other way. CO2 and temperature, they're able to, you know, track pretty closely. You know, the rise in CO2 in parts per million and the average global temperature over the years. And when they lay them together, you get a graph that looks kind of like that. So is the observed warming that we're seeing, is it natural or human caused? Well, maybe I need to keep this closer. So you have here, if it was natural, you'd have this line down here. If it was, you know, if it was not caused by CO2, if you didn't have the increases in CO2, this is the warming that would be happening. You know, but with the observed temperature is going up, and if you put into the models the CO2 that we're adding from fossil fuels, etc., you're able to predict pretty closely to the actual observed measured temperatures. Here. As I said, the last 10 years, or in 2023, the last 10 years, but we've had 3 years now that are warmer, so the last 13 years have been the warmest years on record. In fact, in this century, in the last 25 years, there are only 1 or 2 of those years that are not in the top 25 or 26. You know. Warming by region, you know, they're able to measure where the warming is happening the most and the least, and the Arctic actually is warming the most, the Arctic region. And that actually helps explain a little bit, well, yeah, we'll leave that alone. And here are the observed temperatures in the United States. And of course the red means it's warmer than normal, warmer than the average. And this is what has been happening in the United States. And you can see in particular in the West, the temperatures in the West in particular have really been increasing. And in the winter, actually a little more than the summer. You know, winter temperatures tend not to get quite as cold as they used to. There is a climate shift. You can see here the whole climate. And again, I want to make the difference, the distinction, and this is again where Trump went wrong. You have to distinguish weather from climate. And it is actually easier, even though climate change, we're predicting the climate over 50 years, 100 years, 1,000 years, that is easier to predict than tomorrow's weather. Because tomorrow's weather has all this variability, but it all gets smoothed out when you look at it over the long term. And over the long term, you see the climate. You know, this is what the climate used to be like. And we have some cold weather, we have some warm weather over here, and you know, your average. Anymore, the whole thing has shifted over. So the cold days tend not to be as cold, but you still will get some in the extreme cold, which is what we experienced in the last couple of weeks across most of the United States. You still get those extreme colds, just not as often as you used to. And conversely, on the other side, we're getting more extreme hot weather that we used to not get at all in the start right here. And that is things like the heat dome that we experienced in 2021, when it spiked up to 115 degrees. Another way they can tell is just by looking at record high, record low daily temperatures by decade. And you can see. So imagine in a perfect world, and things are constant. Occasionally you're going to have a record high day. Occasionally you're going to have a record low day. They will balance out. You will have roughly the same number of record high days as you will have record low days. But in a warming world, you are going to have fewer record cold days and more record warm days. And in fact, the ratio now is about 10 record warm days compared to 1 record cold day. Heat waves are more frequent. You know, the frequency and the length and the frequency, the duration, and the intensity of the heat waves have all been increasing, as you can see from each of those graphs. Major wildfires per decade have been on the increase. And again, you can see from the bar graphs for the different continents how they have continued to climb decade by decade. There are more extreme rain events, same kind of graph. You can see the more extreme rain events, and I will explain that in a second. There's ocean acidification. The oceans are acidifying. CO2 makes water acidic. Soda pop is acidic because of the CO2 in it. And as we add CO2 to the atmosphere, actually the oceans absorb 75 to 90% of that CO2. So it is making the oceans more acidic, which makes it harder for shellfish and other calcifiers like that, calcifying animals to grow and to prosper. It also affects coral reefs, yada, yada. So, and again, you can see the graph there, how it is increasing. The ocean heat content, again, not the temperature of the ocean per se, it's the heat content. How much, it's like, which has more heat? Which has more heat? The little saucepan on your stove or the big soup pan? They're both the same temperature, but the big soup pan has a heck of a lot more heat. Okay? So the oceans have been absorbing a lot more heat. Yes, the temperature has been going up as well, but there is a lot of stored heat in those oceans that at some point is going to come out and warm the planet even further. And again, the warmer ocean temperatures, we do see, in fact, warmer surface temperatures and some of the subsurface temperatures down to about 2,000 feet or so. And that makes for more powerful hurricanes. Again, going back to the very first slide, energy and climate change are related. Climate change is an energy problem. That's, I think, is how I said it. The heat is a form of energy, and those warmer surface waters make for more powerful hurricanes. It gets the spinning going faster, it pulls up more heat, and they are more powerful. And again, that is what indeed we have been experiencing. And here is the strength of hurricanes related to ocean temperatures. I had a booming voice. Oh, it's for the recording? Okay. Okay, so the dotted blue line is the actual temperature of the ocean, the sea surface temperature. The orange line is what's called the power dissipation index. It's how much heat it actually releases, the strength. It's related to it's a measure of how strong the hurricanes are. And so you can see how closely related they wind up being. Category 4, Category 5 storms have been on the increase, as you can see from the purple numbers going to the yellow numbers over the last 30 years. Sea level has been rising. Now, when the sea level rises, the importance of that is twofold, at least twofold. First of all, of course, is at some point it will submerge things. Well, it's not going to submerge things at a couple of millimeters or centimeters that it's going up now, so well, it has been a 10-inch rise since 1880, a 4-inch rise since 1993. Well, what's the big deal of 4 inches? Well, you have to project that out into the future. But the two big things that happen from the higher sea levels is the storm surges wind up coming into the cities along our coastlines. The storm surges are stronger. It is now pushing more water along the coast up into our habitable areas. Secondly is you have to imagine 4 inches doesn't sound like much, but imagine on the beach. 4 inches, and that water over here is just 4 inches higher. Well, it means it's going a lot further onto the horizontal distance of that 4 inches is a lot stronger or a lot further than 4 inches in height. That water is coming a lot further inland as a result. There's the loss of mountain glaciers. Melting Arctic sea ice. Again, they've been measuring that over the last 15 years. The last 20 years now, it's the lowest on record. This is, coming back to politics, this is why Greenland is so important. And it's kind of twofold. It's not actually, it's going to take a long time for Greenland to melt. So the resources they talk about, yeah, we can get some, but it's going to take a while for Greenland to be, really mineable in any meaningful sense. But in the shorter term, the melt, okay, Gwen Ellen. What's happening now is because the Arctic sea ice is melting, you have this whole passageway coming through from along the Siberian coast, Russia, of course. And that will allow Navy ships, naval ships, military ships from China and Russia to patrol that area a lot more and make some incursions. And it opens up trade, particularly for China, to come over to Europe. And that's why Trump administration, I think, felt it is so important to control Greenland. Well, they have a point. Greenland is important. So the point I'm making is because of the seamelt, Greenland does take on added importance. The way they're going about it was just bananas. The jet stream is altered. The jet stream normally circumnavigates the polar region fairly smoothly if you have a strong jet stream. But with the warmer climate, you have the thermoclines. I won't get into that. You have a weakening because of these thermoclines where the difference between the polar regions and the tropical regions are not as extreme as they used to be. So the thermocline, instead of being like this, is more like this. It's a little, it's not as steep as it used to be. The steepness would keep the circumnavigation of the polar, the polar region fairly stable and close around that. As it weakens, as it becomes flatter, that thermocline, you get a lot of it meandering out. And so we're having more storms come down from the Arctic. Not that we're getting more storms coming down from the Arctic, but they are reaching farther. They are going down to Texas, they are going down to Georgia, places like that more frequently than they used to. How can climate change cause both drought and extreme rain? That is one of the more common questions. That is one of the more common questions I have been asked, because it seems so contradictory. But what's happening is warm air evaporates and it holds more water. Did I get that right? Yeah. Yeah. The warmer air evaporates. So the air up here is holding more water, evaporating more water from the ground surface, and it gets up into the air. More evaporation on the ground makes for a drier agricultural season. And then when that more accumulation of moisture up in the air, as humidity, and humidity levels have been increasing. So as you get that humidity up there, the rain events then when it finally does come out are more intense. And so you get more of these, Asheville and Texas flooding events and extreme rain events like that are happening more frequently. Does that make sense to people? Did I explain that well enough? There's also a big lag effect. Both sea level rise and temperatures continue to rise for centuries. CO2, unlike some other pollutants that might go into the air, does not go away in 5 years. If we stop burning CO2 now, the temperatures would probably continue to rise for a while, simply because you're going to have a lot of heat that I talked about that is stored in the oceans is going to come out and continue to rise the heat of the planet, even though we aren't burning any more fossil fuels. We've stopped, which we're obviously not going to do, overnight. But even if we were to do that, temperatures would continue to rise for a while. Maybe they wouldn't rise quite as fastly. Grammar, English teacher, somebody. But it would happen. And so you have a much longer lag time. The CO2 stays in the air for, it has a half-life of 120 years. So you're really not even going to start to see any significant leveling in the temperature for more than a century. And it's probably not even going to really start to go down for 1,000 years. So we have a long-term problem here. This is not something we can finally decide, yeah, those climate guys, they were right back in 2010 and 2015. They were right, we should have done something, so we'll do it now. That's too late. Then there's the paleoclimate data, which we're able to tell. I'm not going to get into a lot of detail here, but the paleoclimate data is looking back through tree rings, it's looking back at ice cores, and you're able to tell from some of this stuff what the CO2 levels were by bubbles in the ice cores. You're able to tell the temperatures from the tree rings, whether the annual growth rings have been big or small. You can start to tell when there have been drought periods. And they can put all this together, and then they look at the forams in the ocean, and they're able to put this all together and kind of come up with what has happened to climate over not just centuries, over eons, over the last hundreds of thousands of years. This is the Earth's temperature in the last 500 million years, and how am I doing for time? Okay, so you can see a long time ago, and this is, 400 million years ago, but back then this was, start to get into the age of the dinosaurs at 250 million years ago or so, the temperatures were a lot warmer. Then we entered at million years ago, 5 million years ago, thereabouts, we started to enter into the Pliocene era, the Pliocene and the Pleistocene. And temperatures started, the CO2 had been drawn out of the air a lot more by vegetation. It was plant life, the advent of plant life that allowed, because the planet back here didn't have the diversity of plant life or animal life that we have now. It was much more primitive. As plants came into the planet, they started to absorb CO2 and started to draw down CO2 from the atmosphere until we finally get into a stable period. Then we get to the last glacial period where we're talking, last 100,000 years, and you can see, as we pull out of it here, the current interglacial, where there was warming from the last ice age, we have leveled off, and now with all the CO2 going into the air, we are going up and up and up. And we are starting to approach levels that we have not seen for the last 30, 40, 50 million years. Conclusions from the paleoclimate data is that CO2 and temperature are strongly coupled, and that CO2 is at the highest in the last 3 million years. Temperatures are at the warmest in the last 130,000 years. Okay, and we're getting warmer. And the ice age happens whenever CO2 drops below a certain threshold, which we don't have to worry about right now. But anyway, they're able to determine various things from the paleoclimate data. I'm going to skip that. projected emissions and temperature, if we don't do anything, no policies to curb carbon emissions, this is the projected what happens to temperatures between now and 2100. It goes up to, where are we? Oh, I've got it right here, sorry. 7.5 to 8.5 degrees Fahrenheit. Okay, that's if we do nothing. We're probably going to do something, but, because there are already policies in place, at least worldwide. The U.S. decided we don't need to pay any attention to those policies. But under current policies, the temperature would still increase 3.1 to 3.7 degrees centigrade, which translates to 5.5 to 6.5 degrees Fahrenheit. With the pledges from the Paris Agreement, which we dropped out of recently, but from the Paris Agreement, which was 2015 or 16, it was one of the last years of the Obama administration, worldwide agreement, various nations around the world made pledges what to do with their carbon emissions. And if everybody held to their pledges, the world temperature would still rise 2.5 to 3 degrees centigrade, which would be 4.7 to 5.8 Fahrenheit. And yeah, we are currently on track for probably we're basically at 1.5 now, centigrade, 2.8 Fahrenheit. Most scientists now say that 2 degrees is locked in. We're going to rise at least another, that is locked in, that we're going to go to 2 degrees centigrade. So we're going to go past the 1.5 degree threshold that the international community thinks is good. But that's like a minimum. They're saying that's locked in. Chances are, and the probability is, it will go up to 2.5 to 3 degrees centigrade, which 2.5 to 3 degrees centigrade will be about 4 to 5 degrees Fahrenheit. And that's your average temperature, 24/7, 365. Then there are tipping points. They look at tipping points. You have the Amazon forest is dying back. And the Amazon, of course, absorbed a lot of carbon dioxide. And you can see how it is shrinking. Tipping point, which I talked about already, is the melting Arctic sea ice. And by tipping point, I mean when these things go away. When that ice goes away, right now the ice is providing a reflector from the sunlight. It bounces, it reflects the sunlight back up to the sky. It does not, the planet doesn't absorb it. As the ice melts, that sunlight is going to be absorbed by the water and store the heat. It's going to lock in even more temperature rise. Same with the Amazon forest. It absorbs CO2 as those trees are removed. It's not removing the CO2 anymore. Where else is it going to go? It's going to go into the ocean. It's going to go into the atmosphere and warm our planet even more. These are called tipping points because they are big ones. If we let these things go away, it's not going to be a gradual increase in temperature. We're going to see spikes. We're going to see big jumps from where we are today. Am I making everybody happy yet? Yeah, kind of compared to, I kind of meant to say compared to what's going on. I used to think climate change is the biggest issue. What's going on right now in Minneapolis is, and what's happening in America just frightens me, but yeah, that's an aside. Tipping point, another tipping point is the peatlands and melting permafrost up in Siberia, northern Canada, Alaska. As the permafrost melts, there's a lot of peat there. It has a lot of carbon that's stored. That carbon is going to go somewhere again. It's going to evaporate, come up into the atmosphere as it decomposes. As it exposes itself, as it gets exposed to the air, it's going to get exposed to the bacteria that's going to eat it, break it down, put it back into the atmosphere. Collapse of some of the glaciers. The Thwaites Glacier in particular, there's this huge one in, it's the size of the state of Washington, in Antarctica. and it is near collapse. It is in a bay, well, you can see it here. It's in a bay, it's coming down, and the bay goes down, then there's this rise of the ground, and that has caught the glacier from behind it. It has trapped it, and it has been that way for centuries, and it used to be that it was frozen all the way down. And as the temperatures warm, it breaks off more here, so you're getting close to this point here where it's not holding it anymore, and you're getting water that seeps underneath it, which is melting it from below. When that happens, excuse me, when that happens, that glacier basically breaks off. They have nothing stopped, it's gone, and it will migrate into the ocean and cause sea level rise pretty quickly in the matter of a couple of years. I mean, when I talk about sea level rise, I'm talking about, you know, 2 feet, it says. And that could happen, you know, when that happens, that's not going to be a gradual couple centimeters a year. That's going to be pretty quick. The Greenland ice sheet is melting. The ocean conveyor belt, which transports heat around the world, and it is breaking down. Make this thing easier to find the on-off switch. So, the ocean conveyor belt, you have cold air, cold water. Yep, I don't know how this goes. This confuses me every time I look at it. At Greenland, you have the shallow water. It hits the cold water. So the shallow, it warms up as it comes across the equator, picks up heat, hits Greenland, it cools off, it sinks back down. And that plunging is causing a vacuum. It sucks more air here as this goes around here until finally it warms up enough over on this side in the Pacific, comes back to the surface. That's what keeps, you know, it's a way of transporting heat around the world. It is what keeps Europe, which is a very northerly latitude, it keeps Europe warm. With the global warming, with the climate change, this conveyor belt is threatened to shut down. The temperature differences between the deep and the temperature differences within the ocean water will be such that you won't have that plunging anymore. And that will shut down the ocean conveyor belt, and that could plunge Europe actually into another ice age. That's why Europeans tend to take climate change a heck of a lot more seriously than the United States does. They're also a little bit smarter, I think. Whoa. Okay, so how are we doing for time? I actually made it through. Unbelievable. 10:48. Okay. Questions? We had one go. We have a bunch of them. First hand up was back there. Mark Blackburn did not get his automatic question hand up first. Oh, here we go. I think Neely was first, and then from there, I don't know where it goes, but.
Hello, Debbie Robinson here, and I thank you so very much for your candor and presenting the facts regardless of whether some may want to hear them. The comment I wanted to make was, as a former 7th grade science and math teacher, that is the year where you, if you don't recall, I know it's way back for me anyway, median, mode, and averages, mean, is discussed, and the science there is where you first do graphing. And I wanted to mention that climate is explicitly talked about as being differentiated from weather in the 7th grade.
In the 7th grade.
So as
Good for them.
teachers,
Good for them.
which I was, I don't know how we make more of an impression on folks at large about how important these issues are. But I have so many questions, I don't know which one is more important, but I'm wondering, since Europe takes this so seriously, do you have any idea how we can combat this lackadaisical attitude in this country?
I do not. Plain and simple. I mean, you know, we have been, like I say, I've been involved in climate change, dealing with climate change. I started in energy in the late 70s. By the mid-80s, we were starting to pay attention to the climate change. By 1988, James Hansen made his famous talk or presentation to Congress, which basically said definitively, we have the footprint. Climate change is happening. It is here. We can measure it now. And to me, that was a turning point. And what is that? That's 37 years ago?
Yeah.
You know, and not only have we not made a lot of progress, we actually did with Biden. You know, the Inflation Reduction Act included more stuff for, you know, addressing not so much climate change as renewables, you know, and some automobiles. But in other words, it did tackle the issue. So we made a little progress during that administration. But now we're not only back to where we were, we are regressing. I mean, we are pre-1987. So what can we do? Well, you know, write your congressman, talk to people, and just don't stand for the bullshit.
Right here.
Okay. John, thank you for doing this. Assuming that humans act as humans and we don't change, and we continue on with the course we have now, the tipping points tip, what does our world look like? And I noticed that the climate through the years does go through peaks and valleys. Assuming that we're moving up to a peak, we don't stop it. You know, Greenland is no longer has an ice sheet and all that. What does our world look like? And then what would cause nature to actually take control and to get it back into a median?
That would be a thesis for somebody to answer that. I will get a little bit into that here, I think, in the second half. But the consequences, it doesn't address your question about nature so much. I don't have an answer for that. It is a very good question, but I don't think people have looked at, you know, how long it would take for nature per se to bounce back. I think it's more just looking at how do we stop this, you know, freight train. How do we stop this freight train coming at us, and what are the consequences going to be? And so I can answer your question a little bit on the consequences, but looking beyond that, I don't have an answer.
Hi, John. Bob, thanks very much. Good presentation. The graph on the conveyor belt is inaccurate. The northern flow is on the western side of the Atlantic. And it doesn't matter. It's the general idea.
You're
and
right.
The
You are
Humboldt
right.
current wasn't shown at all.
You are right. I looked at that graph, and it's like, exactly. That was
But the general idea is the important thing.
Yeah.
The question I have was something you didn't mention, but something that frightened me since I learned about it. The methyl hydrates on the continental shelf, if they melt, that's a release of methane into the atmosphere. And if I understand it correctly, methane's a lot more dangerous to global warming than even carbon dioxide. So, how close are we to that risk?
I don't know how close we are, but it is a major risk that we have to be paying more attention to. The methane hydrates for people are a little, they're not quite, but they're kind of like an ice crystal. You know, it's a crystalline form that traps methane, and it's at the bottom of the ocean, up in the Arctic area. And the cold water, or the cold temperature forms, you know, it's like I say, it's not exactly ice. I don't know that I can quite explain it, but it's got ice trapped in there. As the ocean warms, those methane hydrates melt, and it releases methane up in, you know, through the water. You know, it bubbles up through the water, and there are places on the ocean floor that they have filmed where you see the methane bubbling up from the clathrates going. Now, at this point, it's still at a small scale, but they are able to detect that methane bubbles bubbling up to the surface. And when it gets in the atmosphere, it has 80 times the impact of CO2 in terms of trapping heat. Now, the one advantage is it doesn't necessarily hold it for centuries. It only holds it for about 1 century. You know, half-life of about 30 years, and about a century or so is, you know, how long it holds it. But it's doing a lot more warming during that meantime. And so methane is a major concern. We're starting to see some melting of those hydrates. I don't think we are close to it exploding, you know, so to speak, but it's something that people are not paying enough attention to.
You know, when people talk about the small change in temperature for the planet, we think about CO2 because it's a gas that we can control and a gas that we produce, but we don't really think about the biggest greenhouse gas that affects the equation, and that's water vapor. And you did touch on one of your slides with warmer air holds more water. It's dramatic. The amount of water that can go into just a slight increase in temperature can really increase the holding capacity of water vapor in the air. And when you multiply the size of our oceans with the size of our atmosphere, water vapor becomes the key driver in climate change that people don't really think about. But I think that change in concentration changes our understanding of how a small change in temperature can really have a dramatic effect. What's your thoughts on water vapor?
Well, absolutely. I mean, water vapor, and technically Mark is right, water vapor is the bigger, it causes more of the heating, but it is the CO2 in the atmosphere that sets it off. It's kind of a chain reaction. It warms the planet a little bit. That pulls more moisture into the air. That extra moisture doubles itself, you know, and causes, you know, even more warming, which then releases, you know, and then we keep putting more CO2 in. So, you know, ultimately, you've got a lot more moisture in the air, and it is, you know, holding a lot more heat. But but the cycle, what you're doing is you have a cycle of, you know, it goes up into the atmosphere, you know, the water vapor, it's going to rain down and stuff. But what you're doing is, on a longer term basis, you have more water up in the atmosphere at any given time, and then, you know, less in the land. I mean, you have that drying process. It is still a cycle. Ultimately, it's the same amount of water that is circulating, but it's going to have different effects. And just one more point on the water. Every degree of warming puts 7% more water into the atmosphere. Every degree Fahrenheit of warming puts 7% more water into the atmosphere. And again, it's a greenhouse gas.
Hi, John. Let me just point out, I was the first one to raise my hand, and still Mark got to us. So I think there's some discrimination there. My question is, and I think it's a data point that some of the people who claim climate change is a hoax, which unfortunately has taken over this country, is that there was a rise in temperature eons ago. What was the reason before the dinosaur age, and we saw that in your chart as the temperature went up and then fell down, what was causing the CO2 release at that point? There were no fossil fuels being used, so why did that happen?
Mark's saying algae. I was going to say it is the, and I think we're going to have a talk later in the semester that may address.
Volcanic eruptions.
It's volcanic eruptions. And you didn't, yeah. Volcanic eruptions put the CO2 in the atmosphere, and you didn't have the living plants to suck it out at the time. And that's a simplified version, because Mark also touched on something, but but that's kind of a simplified version. So I think that's really probably all we have time for right now.
We'll take a break and keep your questions until the second, after the second hour.
Okay, are we ready to go here? Okay, I'm going to open with another joke. Okay, this one's not as good as the other one. Okay, never argue about climate change. It always turns into a heated debate. Okay. So the second half, we'll be talking about the consequences of climate change, and then if I have time, we'll get into some recommendations, what we might be able to, what we should be doing. I don't know if it's what we might be able to do, it's what we should be doing and what we're not doing. What are the likely consequences? Well, the consequences, it's not going to be the end of life on Earth. It's probably not going to be the end of human life unless we just let things get so bad and don't do anything, but it's not going to be that. Is it going to be the end of human civilization? Again, probably not. It's not going to be that bad. But what is certain is that changes are inevitable, and the changes are going to be worse than what we've got today. I mean, they're going to cost us. And those costs, those impacts will be significant and severe. It may not be the end of civilization, but it doesn't mean it's something that we want to voluntarily live with. The best case is that things will be slightly worse than today, but that means we have to do things to, to control emissions and start taking CO2 out of the atmosphere. But the best case is, just slightly worse than today. The worst case is where the impact gets bad enough that you're going to really start to see social breakdown and dystopian futures, okay? At least in some parts of the world. And the most likely is probably something in between. It is going to be disruptive, it's going to be costly, we'll be responding to emergencies, and it's going to sap the economy. Okay, the natural consequences fall into four main areas: drought and heat, wildfire, rising sea levels, and extreme rain and hurricanes. So those are the four natural consequences that we are going to be experiencing. Societal consequences will be health impacts. I won't get into all the details, but health impacts, for example, from breathing wildfire smoke. There'll be agricultural impacts. The droughts are going to, significantly disrupt agricultural production, or threaten to. Whoops. There'll be forest impacts, water resource impacts, impacts on coastal areas, yada, yada, yada. Okay. One of the consequences is sea level rise that I talked about already a little bit. Low-lying cities will be inundated, and I give some examples there: Venice, London, Amsterdam, Miami, New Orleans, on and on. But low-lying cities at some point will be inundated. It's going to happen tomorrow? No. It's going to be happening in 20 years? Well, In 20 years, depending, especially with things like the Thwaites Glacier, if something would really happen with, that glacier or some other glaciers of significant size breaking off, you could see, sea level rise enough that you really start to see some flooding in places like Miami, which already gets flooded, at times of the year, and Venice in particular, so. There will be more destructive storm surges that I mentioned. There will be sewage system overflows as a result. So, you can extrapolate and just go on and on with what impacts are going to be. One of the major consequences is extreme heat, such as the heat dome that we had in 2021, where it hit 115 degrees here, 117 degrees up in Lytton, Canada, which then had a wildfire which destroyed the town. Okay, because trees are not ready for they were not evolved to withstand those kind of temperatures. But heat is a dangerous natural disaster. It is the most natural disaster. It can cause heart attack and heat stroke for humans. Heat deaths are up 50% due to climate change. And this is where I'm I have to kind of read things instead of just talking to you guys. Half the world population will face dangerous heat by the year 2100. Half the world's population. Now, where is that going to be? Well, most of that's probably going to be in the tropical and subtropical areas. Equatorial Africa, the Middle East, probably Central America, South Asia, places like that. Is it going to happen in Detroit, Michigan? No. But you could occasionally get days, even in some of the cities in the United States, like happened in Portland, where you have a unique event that will cause a spike up to 115 degrees. The danger is not just that it's uncomfortable and can kill some people. The real danger is when you combine that with humidity. So you get a wet bulb temperature of, it's called a wet bulb temperature of 95 degrees. Basically, or it's a 35 degree wet bulb temperature. What it is 95 degree temperature, 100% humidity. That kills people. The body needs a way to evaporate heat. And if the temperatures, and particularly the humidity with the temperature, rise high enough, the body has no way to expire its heat anymore, and you will die. Heat death. And it is a very unpleasant thing. And more places in the world are being at risk of these kind of events, and in some places will probably become uninhabitable. Places in India and Pakistan, they say, may wind up being uninhabitable. I don't know how soon, 30 years, 50 years, but on the trajectory we're on, places of the world will be uninhabitable. Extreme drought will cause reductions in food production. River traffic will be affected. A couple of years ago, again, when I did the first talk here, 2023, river traffic was affected on the Mississippi River because the water was so low going down, so the barges could not make it up and down transporting grains from the Dakotas and Iowa down to the ports in New Orleans. Panama Canal was low, and the Yangtze River in China had same type of problems. So you're going to have those kind of problems. You're going to have, with the extreme drought, you're going to have vector-borne diseases, more vector-borne diseases around the world. Everything from Lyme disease to Rocky Mountain fever to spotted fever to, somebody could probably name 5 more that I haven't listed there. Hydropower is reduced, so we're going to have to get more electricity from other places. There will be fish and amphibian die-offs in the warmer rivers, warmer lakes, and shortages of drinking water. Food production will be adversely affected. Heat offsets the higher benefits of CO2 levels to growth. So CO2, indeed, is plant food. Some people get up and say, oh, CO2 is plant food, we're going to have a greener planet. Well, yes, it is plant food. Plants, need CO2 to live. Exactly. They are absolutely right. But the effects of heat closes down the stomata on the plants, that they can no longer, they shut down during the day so they're not taking in CO2. And that effect offsets the benefits of supposedly more CO2 in the air. In addition, plants that are growing in higher temperatures tend to have, it changes the nature of the plant. They have less protein. More leafy, you might get the same weight, maybe even more weight, but you don't have the same nutrition levels. There'll be cattle die-offs, lower milk production per cow. Chickens will cost more, eggs will cost more, as the poultry houses have to be cooled. There's wildfires, loss of life, loss of property, public health, poor air quality, smoke damage to crops. And we're seeing that in Oregon with a lot of the wine crops. They're actually, detecting, smoky flavored wine grapes, smoky wine grapes. Tainting the taste of some of the wines that are grown now. And one of the big ones at the bottom that I think I have a different slide that deals specifically with it is climate refugees. And all these things, the heat will cause climate refugees, out of Pakistan, out of India, out of Central America, etc. Extreme rain and stronger hurricanes. Again, I had the slide in the first half of how the more water in the atmosphere, it's a cycle, and it will come down as rain eventually, but only in the cooler, rainier seasons. And one of the unique things of climate change is dry climates will become drier and wet climates will become wetter. So there's a distribution, change in the distribution of where the rain falls. Plant and animals will have to move. They'll have to migrate, either up the mountains, but if they go up the mountain, there's no further to go when they get toward the top. If they move north, hopefully they can maybe go north again and north again. But animals will have to move, migrate. And that doesn't happen quickly. It takes, trees in particular, it's going to take generations, for them to move. They'll move slowly, as they propagate. Impacts in the Northwest, in the interest of time, I'm going to skip that. That's just more of the same, but try to make it specific to Oregon. Public health, I mentioned heat stroke and heart attacks, vector-borne disease, respiratory issues from wildfire smoke. Allergies will be exacerbated, be physical and mental stress from coping with more heat all the time. Hunger and malnutrition, and work productivity will also decline as people will be forced, as they already have in agricultural fields in California and other places, where they are starting to work at night. Construction crews having to work at night, because there are too many days. If they work in the daytime, in the summertime, the temperatures get too hot for them to be out there working. Climate migration. This is a huge one. 250 million people worldwide have been displaced in the last 10 years. Let that sink in. 250 million people. So, and I'm not going to be, not going to be cavalier about it. I don't know what the word is, or 250 million people is driving the immigration crises that we currently have. And we do have immigration problems. That is not to say how we are dealing with them is in any way civil, but there has been an increase in immigration, and that has, at least the perception of it, if not the reality of it, is causing backlash. Because people are feeling, more and more people. Even in the United States, not that we feel it there, but in the United States, 3 million people have been displaced in the last 5 years. Forced from their, I should say displaced, I should say forced from their homes. Some of them are able to return to their homes, and I don't mean people who leave for a hurricane and then come right back. I'm talking about homes that have been destroyed. and they have to leave their homes. Now, some of them rebuild and come back to that area, but a lot of them don't. 3 million people have been forced to leave their homes because their homes have been destroyed in the last 5 years. Economic cost to society, well, who knows? But on the right side, you can see, like I said, last year alone, the estimates in the United States were 115 to 250 billion, not million, billion dollars of impacts in the United States alone from climate events. And you can see the list of some of the things and what some of the costs were. The $100 billion plus climate events, individual events that cost more than $100 billion. You know, the wildfires in California, Hurricane Katrina, Hurricane Ian in 2022, Hurricane Maria in Puerto Rico, 2017, Superstorm Sandy in New York, 2010. So it is costing, you know, it is costing society a lot of money to deal with these events. And the global poor are the ones most at risk. You know, the advanced societies like the United States and Europe are going to be able to withstand the impacts a little bit better because of the infrastructure that we have, the air conditioning, the others, whatever it is, you know, across the board, we will be able to withstand it better than the global poor. Why is 1.5 degrees such a big deal? Well, the warmer it gets, and they say every 1/10 of a degree matters, the warmer it gets, the worse the consequences will be. And that is absolutely right. Every 1/10 of a degree warming will exacerbate the consequences. And it goes up not just on a linear curve, it's going to go up on an exponential. Take it out of my membership. There's a word for it, dramatic. Okay, little, where were we? And the 1.5 degrees is kind of a consensus among the scientists. There is no hard and fast rule what the break point is. It's just that their estimate of what happens when temperatures reach 1/2 degree, 1 degree, 1.5 degrees, 2 degrees, 2.5 degrees on sea levels, on which they're able to predict fairly accurately on that one. But what will happen with agriculture? Well, they can make estimates, but it's not quite as exact a science as, for example, the rising sea levels. But they can make these projections, and they have kind of come to the conclusion that 1.5 degrees thereabouts is kind of where we need to be setting our target and stand below. Because as we get past that 1.5 degrees, the impacts are going to ramp up at a even faster rate than we're already seeing. And here you can see the under various temperature scenarios in the future, various future temperatures, you can see extreme heat goes from 4 times more likely to 9 times more likely. Heavy rain goes from 50% more likely than normal, than the 1950 to 1980 average, which I think is the baseline that they use, you know, before climate change really started to impact. So even at 1.5 degrees, extreme heat events are 4 times more likely than they were in the 1950 to 1980 period. By the time you reach 4 degrees, it'll be 9 times more likely. Heavy rain, up to 3 times more likely. And you can see the increases from drought as well. How did blanks get in there? Oh, okay. Part 3. So I've given you the science. Some people don't understand the science. It's going to be hard to convey the science. Why should you believe me? Well, don't believe me. Believe these people that I'm going to show you next. First of all, the scientific community. Now, science is not in the greatest graces anymore under current, political structures, especially in the United States. But basically all the major scientific organizations in the world, the Royal Society, Great Britain, the National Academy of Sciences here in the United States, the National Research Council, NASA, NOAA, the National Oceanic and Atmospheric Administration, physical societies, the Scripps Oceanic Society, they all concur with the assessments of the impacts that I've described, of what is going to happen with climate change and what the impacts will be. So, do you want to believe the current administration, or do you want to believe people who have studied this issue for many, many years, working together? Your choice. So there's the International Panel on Climate Change, which is international panel. It represents basically all the countries in the world. They send some of their top scientists. They work together over the course of a couple of years, and every 5 years they issue a new report. And each one continues to get worse. We used to do climate assessments. That's one of the things that no longer will be happening under the Trump administration, but we used to do climate assessments. It typically involves 20 federal agencies, six of the 9 national laboratories, 40 plus universities, some of the major universities in the country, and a number of businesses and NGOs. And they come to the same conclusions. It's complex and multidisciplinary. You have to look at all these disciplines. Physics, atmospheric sciences, chemistry, environmental chemistry, earth sciences, geophysics, on and on and on, meteorology. These are the people that are involved in the studies that I just mentioned. It is a worldwide effort, involving all these disciplines. Why should we believe science? Well, science is our surest and most universal way to gain knowledge. Plain and simple. It is empirically based. It is based on evidence. What makes it so effective is you test to try to disprove a hypothesis. If something is disproved, you throw it away. You can never really quite prove something, but you can disprove it. When it's disproved, it's out the door. And the other is peer review. I worked at the National Laboratory. We did this a little bit at the Department of Energy when I worked there, the Oregon Department of Energy. But at the National Laboratory, anything that we wrote and had to publish went through significant peer review. I had to have it reviewed by 2 people inside the agency, 2 other scientists inside the agency, 2 people outside the agency. And then, of course, they'd have to go through the writing process. But we had to send it to independent people for review, and we had to address those comments. So when they say something is published in a peer-reviewed journal, that's what it means. It is not just somebody writing something on their own, not getting peer review and expecting it to have equal weight. In addition to the scientific community is the military establishment, the defense community. I like this. It's not as good a pointer anymore, but I feel more like a conductor here. The Defense Department, pre-Donald Trump, pre-Pete Hegseth, which has been decimated at the top ranges, they have concluded that, among future trends that will impact national security is climate change. Scientists are converging toward consensus. Climate-related effects are already being observed, and politics or ideology must not get in the way of sound planning. Unfortunately, the last one is ixnayed. So, and you know, they have done their, each military branch has done their own analysis. I think I've got a slide showing that. Anyway, the military calls climate change a threat multiplier. So it is not going to necessarily cause some of the military problems, you know, but problems that come up in the world will be multiplied by the effect of climate change. Now let me give you an example, and this goes back a number of years, you know, 10, 15 years, is in Syria. And Syria had the classic conflict between the Sunnis and the Shias. And there was conflict, and it was, you know, you had Bashar Assad as the dictator there, and he was brutal, and people resented it and hated it, but they lived through it. And there was a lot of conflict that kind of simmered down. But then they went through an extreme drought for about 10 years. Agricultural output decreased, food prices rose, and there were some levels of famine across the country. That caused the uprising. It was a threat multiplier. The simmering tensions between the Sunnis and the Shias and some other groups in society were the underlying cause. That was there. Climate change came along and broiled it up to the surface, and they had the revolution there. They had all the, if you remember, 10 years ago there was, you know, all the Syrian cities were being bombed, and, you know, Assad was waging war on his own population. So there's an example where it's called a threat multiplier. And yeah, U.S. military on climate change here. You can see the different branches of the military and some of their different reports. So we have the scientific establishment, pretty much consensus. You have the defense and the military people. So who are you going to believe? You know, you're going to believe the rants and tweets of some somebody, or are you going to believe, you know, the Defense Department or the scientists, you know, thousands of scientists working together? In addition to those groups, you have the business and financial community, which is pretty much on board with climate change happening. It affects their bottom line. You know, they're not going to pay attention to somebody's ideology. They don't give two hoots about somebody's ideology. They want to know what's going to, you know, what's going to affect their profits. So, Federal Reserve Board says climate change is already imposing significant costs, and I've mentioned them in some other slides. It poses a risk to the stability of the financial system, and climate stress tests are a key tool going forward. Financial Oversight Stability Committee, which is advisory to the Treasury Secretary, Scott Bessent, these days. And I don't even know, I presume they're still working, but they're not doing the climate-related stuff that they were. But they had concluded climate change could destabilize the global financial system, unplanned transition could cripple industry and topple banks. And I was reading something about a week ago that about a third of U.S. banks, now mostly smaller banks, not the big U.S. bank or Chase Manhattan or whatever, but about a third of the smaller banks in the United States are expected to go bankrupt here by about 2030, largely related to climate change. The insurance industry is kind of a canary in the coal mine. And they've already stopped insuring a lot of housing in Florida because of the hurricanes and flooding, and in California because of wildfires. So if people can't get house insurance, they can't insure their homes, what's going to happen to the home building industry, which is key to our, you know, to our economic growth, you know, to GDP? It's going to collapse. People won't be able to build homes if they don't. Are you going to lay out $300,000, $400,000, $500,000 for a house if you can't get insurance on it? Then there's the reinsurance companies, the companies that insure the insurance companies. Okay, and Swiss Re Insurance Company is the biggest one in the world. not the only, but the biggest. They say that climate change poses the biggest long-term risk to the global economy. No action is not an option. And they have gone to the extent of trying to quantify a little bit the effects of various temperature increases and what will happen to the GDP. So if we can keep the temperature rise to below 2 degrees centigrade, which is 3.8 Fahrenheit, it's still a 4% drop in global GDP. We're no longer in the growth economy of the past 50, 60, 70, 80 years, the post-war world. If we don't take any actions, or we take some mitigating actions, as the temperature rises as a result, the impacts on global GDP rise accordingly. How are we doing for time? Yeah, getting close. Better go through. The financial sector has put together this net zero banking alliance. These different banks have committed themselves to zero emissions portfolios by 2050. I don't know how they're doing in terms of trying to meet any benchmarks, but that's their goal. Deutsche Bank, just another example, financial sector. This is Mark Carney. Mark Carney, currently Prime Minister of Canada, former Governor of the Bank of England, former Governor of the Bank of Canada. The man knows what he's talking about. Whether you like his politics or not, he is not a dumb man. And he is about as establishment as you come. And he says companies that don't adapt will go bankrupt. The longer we delay, the greater the risk of collapse. And if we don't have a planet, we're not going to have a very good financial system. BlackRock, the world's largest asset manager, $9.5 trillion, says the evidence on climate risk is compelling. Financial risks of climate change are bigger than any other crisis. Tiny steps are not enough. Even Jim Cramer jumps in on it. Climate change is a serious threat to our future. The market doesn't care whether you believe in climate change or not. We will punish you if you don't do something about it. And the religious leaders, we'll skip them. Climate skeptic organizations. Okay, the climate skeptic organizations, who are they? Well, the American Enterprise Institute, the Americans for Prosperity, Cato Institute, Competitive Enterprise Institute, Heartland Institute. So those are probably the main ones that you may have heard of. So they're among the climate deniers. What is unique about them? They are not scientific organizations. They are not military organizations. They are not businesses whose profits are on the line. They are political organizations. They are ideologically driven. And they are all funded by ExxonMobil or the Koch brothers. So go ahead and believe them if you want to. Just telling you. Okay, so here's, pick your excuse. These are the excuses. Get the free one in the middle. You can make up your own. They cherry pick data. And I may... There, did you get that? Anybody get that? Okay, it's going to repeat. Good. Okay, then I can actually get it. So, what's going on here? So they... Okay, so what they've said is over a 10-year period, they were saying this back here, they went from 1998 to 2012 and said, things are fairly flat. In fact, it was making a downturn, proving that, climate change isn't happening. It was going through a downturn. Well, any individual year might be a little cooler than the year before. Doesn't mean climate change isn't happening. You have to look at the data over a much longer term, and then you see that, oh yeah, it's been going up for a long time. Even though these 10 years, it kind of, because of the El Nino, La Nina phenomenon, yada, yada, other things, it maybe, had a little bit of a break. It didn't go up dramatically during that period. But it didn't mean it was the end of it. You have to look at the longer term historical trends, and that's why I say it is easier to predict climate change over a long period than it is tomorrow's weather or next week's weather. So those are the tricks that they try to play on you, and you have to pay attention. I'll go past that. So, Woody Allen, yay. I wish I had some kind of affirmative message to leave you with. I don't. Would you take 2 negative strategies? Messages? Okay, we'll do a quick tour of this, and believe me, this will be quick. No action is not an option. We have to do something. The impacts, whether we meet, whether we do, we have our choices. Our choices are we do an orderly transition or a disorderly transition. And even then, we can try to do an orderly transition, but if it's inadequate, the target is not met, as opposed to if the target is met. And what are the impacts if we do each one? And meeting the target with a disorderly transition is kind of an oxymoron. Not going to happen. Even with an orderly transition, the impacts will still be stable or slightly worse. It'll be a smooth transition. It gives us time to respond and prepare. But the more likely scenarios, I believe, the more likely scenarios at this point look like they're going to be one of these two. We're not going to meet the target. Depends how much over we go, but we're not going to meet the target. Are we going to do that in an orderly or in a disorderly fashion? And even there, that makes a difference. Because if we do it in a disorderly fashion, we're going to be dealing with chaos and system failure, as opposed to just heavy costs. We will skip that. There's a continuum of responses from no action up to cautious action to immediate or radical action. It could be alarmist, which then you become a doomer. And I hope I haven't made doomers of you today, in which case you're back to no action at all. I need to see where I'm going with this. How much time? Reasons for hope, well, we know what we need to do. So what do we need to do? What? Take action? Oh, I thought I heard someone say, put our heads in the ground. Oh, okay. We know what we need to do, and the technologies to do it, for the most part, are there. With one big exception, which is removing CO2 from the air, carbon capture. Because really, we can maybe level things off and coast where we are, a little bit worse than where we are, if we did what we need to do and with the current technologies. But to really make impact, we would need carbon capture. And the technology is iffy right now, but it would have to be deployed on a massive scale. And the additional problem is, so if you're removing carbon from the air, first of all, that's a big ask, because it's really diffuse. We're talking 500 parts per million, and you have to now collect that. But then what are you going to do with it? You're going to have to put it back into the earth. You're going to need pipelines to move the carbon dioxide. to places you can move it. Probably some of the old oil fields where we took the stuff out of in the first place. Now we have to go back and put it back. So think of what we have done over the last 80 years, 75 years in the post-war period with all the oil that we have produced and removed. We now have to take all that CO2 that we would maybe capture with a technology that we're not quite sure exactly what it looks like yet, and then put it back into all those holes, move it around and put it back in. It's going to take massive infrastructure. So anyway, most technologies, to keep things at least at a level, fairly level, technologies are there. We know what we need to do. There's, positive trends in renewables and electric vehicles. So we could get there. Don't need that, don't need that, don't need that. The biggest obstacles to addressing climate change, in my mind, are not just the technological ones, they're mindset ones. And I think one of the biggest obstacles is our individualist mindset, that we can do everything, individually. And, you can go, if you believe in this, you can go and stop eating your hamburgers and, go get an electric car and, but that's your choice. Well, no, we got to go beyond that. Second one is that market forces will solve it. Have they done that so far? They've led us into the ditch that we're in. Market forces can help create some of the new technologies through innovation. It has a role to play, but ultimately we're going to need some guidance, some working together, some cooperation. The idea that we can fix it later. As I said before, there is a lag time, a long lag time before things start to look better, even if we stop today. So fixing it later is not an option. Most people think, oh, technology will save us. We're going to come through with some silver bullet. I don't know. The only silver bullet out there is nuclear fusion that I can think of, and that's a long way off, if ever, as a possibility. And the perpetual growth myth, the idea that we can continue growing forever and ever. We're on a finite planet with finite resources, and don't think it's going to happen. Other obstacles: complacency, inertia, confusion. It won't be so bad, it's overhyped. The problem is too big, the doomerism. Is the fossil, again, I wanted to see, there's too much to go through. Is the fossil fuel industry responsible? In some sense, yes. They've known about this for decades. They are culpable, but we cannot just blame the fossil fuel companies. We are all to blame. We were complicit in it. We used their product willingly, knowingly, flagrantly. Maybe that's the word I'm looking for. So we are all complicit in this. And I know that's an uncomfortable truth. It's an uncomfortable truth for me. I mean, I'm as guilty as anyone in this room. It's not like I've done any better, but we have to own up to it. We have to get on a glide path, to dramatically reduce our carbon emissions. 15 years ago when I was at the Department of Energy, 20 years ago, whatever, we were saying we need to cut, to start to reach our targets, we had to cut our energy use 5% a year, our emissions. Individually as well as collectively. We had to reduce our emissions 5% per year. We've gone just the opposite way. We continue as a society to use more and emit more carbon dioxide every year. So now if we were to reach this target, that line is going to be even steeper than it is now. We'd have to be reducing our personal energy use 10% every year. So imagine that. Cut your energy use by 10% this year, starting now. And then next year at this time, make a commitment to cut it another 10%. What are you going to do to get there? You got to be thinking about these things. But we can't just do it individually. It has to happen as a society. We have to make the choices to make that happen. Three main responses: mitigation. We can mitigate the problem. We can adapt. Mitigate the problem means we reduce the CO2 levels. We can adapt, realize we're not going to get back to zero emissions, anytime soon. We need to prepare for some kind of level of adaptation. To the extent that we don't do two things, the third response is suffering. There will be suffering if we don't get busy and do that stuff. It will be a hard scrabble transition. And the three main areas are technical, communal, and internal. All these good slides. Oh man, all this stuff. Come on, I'm just getting started. It's going to take a wartime effort, World War II level effort, or more at this point. I'm getting the sign that we are done, so I think this is my last slide anyway. We need leadership. Unfortunately, we don't have it right now. I actually look to some of the European leaders. I think Mark Carney, I think the leader of Canada right now, is maybe one of the better hopes that we have in the world for, organizing something and taking some kind of, getting the world on the right course. I don't know if he's up to it. I don't know if he wants to do it, whatever, but somebody's got to take the lead, and right now he seems like one of the brighter prospects. So that's it. Oh, there's still more. I can't believe it. Oh, I'll leave you with Woody Allen one more.
Hi, this is Cassia.
Stand, please.
I'm over here.
Okay.
In any event, would you rather have a question about the Arctic or one about non-first world powers and climate change?
I don't care.
Okay.
You ask your question.
Okay. Earlier on, you said that we needed to refreeze the Arctic. I don't understand how that's even possible.
I didn't say refreeze the Arctic. We can't refreeze the Arctic. I think what I said is it's melting. We need to stop them, do what we can to stop that melting.
Okay. All right. Well, the slide seemed to imply that we needed to refreeze the Arctic somehow, and I couldn't figure out how that was going to happen.
Sorry. I'll go look at that.
Okay, that's fine. So I will give up my second question.
I'm sorry, but that's all we have time for today. But of course, I know. John is one of our members. Maybe he'll send us his slides so you can see the rest of his presentation. And of course, he's always around to talk to. So there you go. Have a great afternoon.
Yeah, and I'll give it, Dave will post it in the newsletter.